Thank you for meeting with me, David. How are you doing?
Doing really well. Thank you so much for having me. I appreciate it.
Yeah. How's the show been so far?
The show has been good.
Yeah.
We have had a good amount of traffic at our booth, and coming to a show like this just always blows me away with the breadth and depth of what's going on in the power space.
Yeah.
Right, and how many players there are, and there seems to be a lot of energy and excitement this year too.
Yeah, certainly. And I know ADI's got a lot of energy and excitement, so that's I wanted to talk a little bit about that. The big news was plans to acquire Empower, and for 1.5 billion, right?
Yes.
So for the audience that really isn't familiar, Empower Semi has integrated voltage regulators, and it's based on that foundational FinFET. So using FinFETs for power. So what I wanted to understand was how Empower's technology fits into ADI's portfolio.
So Empower, as you said, does the integrated voltage regulators. They have a ton of other really cool technologies around that. You mentioned FinFETs, there's also silicon capacitors. In a nutshell, what they do is they provide that last mile of power delivery to AI processors, GPUs, because of the vertical power integration, right? Eliminating the distance of traces to deliver that power, improving the efficiency as much as possible, reducing the footprint of the power. And I think in the AI space in general, we're seeing a lot of integration close to those processors, right? You see it with high bandwidth memory. IVR is another example of that. The other thing that we're excited about within ADI is the ability to extend those technologies, right? Great IP, great engineers, to extend that to other applications. And I think one of the big ones that we're looking at is how AI is going to have different instantiations in different areas at the edge. Maybe we call it physical intelligence or whatever, but AI is not just going to live in the data center or in the AI farm, but where else is it going to go, and how can we extend those solutions?
Yeah, that's very interesting. I might ask you more about that.
Okay.
That is quite interesting. So ADI is a vertical power delivery page. This is pre all of the Empower news. There was three main technologies that highlighted that enabled vertical power delivery, and it was the flip chip packaged multi-phase controllers for backside VRM mounting, a smart power stage IC, and ADI's coupled inductor technology. Do you see Empower's sort of Crescendo replacing ADI's kind of distributed discrete system approach, or is there kind of a complementary thing happening there?
Yeah, that's exactly what we see as more of a complementary thing. I think the Crescendo is best equipped for that final power delivery, especially to your really high current GPUs or AI processors, right? The other vertical power components continue to add value in different applications.
Certainly.
But I think the investment from an Empower standpoint is that vertical power delivery to AI processors. That's the big one. But I think it also adds to the IP portfolio in general. And things like their approach to magnetics and other things are technologies that we can continue to innovate on and extend to other applications. It's almost like if you remember smartphones when they came up and they were the big cutting edge of technology. There were so many innovations that went along with those, and then automotive, right? And those innovations extend to other areas, and we're seeing that now with AI.
And actually, when you were talking about the innovations, it seemed the coupled inductor technology seemed especially complementary. And I was wondering, as a long-term vision, do you see ways to integrate ADI's coupled inductor technology with Empower's FinFET technology in this vertical power delivery platform?
So, I think maybe the proper answer is I can't officially say.
Yeah.
But I mean, there's no question
Yeah.
that those technologies are going to be things we're going to look at integrating and exploring how we can continue to innovate in that power delivery space.
Yeah.
To, it's always about increasing efficiency, reducing size, and having really good transient response.
Right.
Those are the three things. And I think from a coupled inductor standpoint, that's sort of the tip of a lot of innovation that we do in the magnetic space.
Yeah.
So I think whether it's coupled inductors or not, you'll see innovation in the magnetics around these power supplies.
Very exciting, and that's Empower's thing, right? The FinFET fast FETs. They're so quick that you need less decoupling capacitance to respond to transients, and there's so many of them now because of the transients that AI has and requires.
You nailed it.
Can you cover ADI's coupled inductor technology in more detail? I know that ADI has its own packaging technique to embed magnetics and passives within the IC. So maybe you could talk about that a little bit.
Sure. So, coupled inductor technology is this super awesome way of placing two inductors in close proximity to reduce the AC flux that you're going to be getting, but still allowing the DC components of the power delivery to be passing through. And by doing that sort of canceling in a tight space, you improve the overall efficiency and transient response, and also reduce the footprint of the solution.
I see.
And if you talk about, you asked also about packaging, magnetics.
Yeah.
So the coupled inductor is a great innovation that we've done. Another area that you kind of touched on is the micromodules, right? And that's where we integrate inductors and integrate a lot of other passives in there, which we were talking about it earlier with some folks on the show.
Yeah.
What's amazing to me is that you have, like, in a micromodule, you have like a stack up of all sorts of different components, each of which have different coefficients of thermal expansion. And you imagine if you heat those up and cool those off, you're going to create all sorts of stresses in there and have all sorts of unknown things going on. And yet, like, ADI has kind of cracked the code on
Figured
that,
it out,
right? Which is super exciting, and another way that it extends to these super high density power supplies.
Yeah, and then I know that the micro modules, they build on that sort of silent switcher technology, but they embed the magnetics, right?
Exactly.
So you have that, as you were saying, that a lot more to consider inside the package.
Yep.
Maybe we could pivot to Power Studio, because I know you were instrumental in that. So can you describe ADI's Power Studio in a bit more detail?
Sure. So ADI Power Studio is really the first step in trying to unify a set of power development tools that we have within the company. And I think a lot of people have heard of LT Spice, right? That's sort of the hallmark. And within that suite, there's also LT Power Planner, LT Power CAD, LT Power Play, which come in at different steps of the design process. With the Maxim acquisition, there's also this EESIM Oasis Simplest component. And what Power Studio does is unifies those, and it's really the first step in developing a better unified process. I think the other thing that I want to say is that we're continuing to support a lot of the other tools. So if people love certain tools, they don't need to worry about losing them, right? But I think ADI Power Studio becomes that single solution that you look for, which is much better for developers, as opposed to them having to go search and create a patchwork of different tools. Other really cool benefits are that it's web-based, and so you can access collaboration, right? I can share a design with you or my FAE or anybody, and we can collaborate on it and improve on it. And also, I think long term, the web-based platform will allow for agentic AI engagement, right?
Okay.
And that's a little bit of a ways off,
Yeah.
but you can imagine asking your AI to go create a power tree or go simulate this or that, and short-circuiting a lot of the manual steps in that process.
Yeah. So maybe we can walk through a specific example of how
Sure.
the workflow is connected in practice. So from the Power Studio Planner through to simulation in LT Spice or Simplest. Yeah.
Right.
Yeah.
Okay, exactly. So, you start in ADI Power Studio Planner, and that's a power tree tool.
Yeah.
Right. So you would say, here's my system input voltage of 12 volts or 48 or whatever it is, and then you can say I've got these different loads in the system. 1 volt at 10 amps, 5 volts at 2 amps, whatever those loads are.
Yeah.
And then you can construct your architecture using a bunch of different products that are in there to decide how you want to configure things. Do you want to convert from 48 to 12 and have an intermediate bus? Do you want to go from 48 down to those point of loads directly? And you can play with different architectures, and at the high level you're getting efficiencies, so you can understand what the overall impact of the tree is. Then from ADI Power Studio Planner, you can go into ADI Power Studio Designer. And you can think of that as like the ADI Power Studio version of LT Power CAD. So it's a it's sort of a tool that allows you to do efficiency calculations. It allows you to do stability, Bode plot types of calculations, and dial in your compensation components. Dial in all the R's and C's that are around your product. Both of those two steps are online, and those are the anchors of ADI Power Studio. And then from ADI Power Studio Designer, you can export to either LT Spice or to Simplest. And that would be depending on what simulation model is in place. So most of the legacy LT parts are going to be in LT Spice. Most of the legacy Max parts are going to be in Simplest. But the process is more integrated to that point, and then once you go into Spice or Simplest, it's the deeper simulation, right? You're checking out, switching across the FETs and looking at ringing and efficiencies and transients, more of those details.
Gotcha. Last question, and then I'll,
sure.
not bother you anymore. So ADI has positioned this as the first phase of a fully connected power design workflow. So with ongoing updates, may I ask what type of updates we might see in the future?
Absolutely. So I think further integrating that process is going to be the big one, and creating a unified platform for customers to interact with. Near term, we don't have any plans to have like an online version of like the LT Spice Simplest, but that is in the plans, and that's where we want to continue fully integrating that process. And we'd like to get it to a point where it can be a unified tool, so that whatever engine might be behind it from a simulation standpoint, it's doesn't matter, right? You're looking at doing a simulation and getting data about your part so that you can put it in your power supply design, and that would be the long-term vision. And then having the ability to interact with AI tools is another thing, having collaboration abilities. And the other thing that I would say is that long term we also respect the fact that a lot of customers still want to have offline tools. Right? A lot of our aerospace and defense customers, or the customers that have reasons to wall off their systems. We're absolutely going to respect that and make sure that we develop tools that can continue to live in those environments as well.
Well, thank you so much for answering my questions. I really appreciate you coming by the booth and speaking with us. Is there any kind of last statements you want to make? Anything I might have missed?
So, thank you. first off, I really enjoyed this, and it's always fun to
Likewise.
talk
Thank you.
and share different things.
Yeah.
I guess the other thing I would say is look out. We've got some other things in the pipe
Yeah.
that'll be coming out in the latter half of calendar 26.
Yeah.
Which will be really exciting.
Yeah.
Definitely some micro-module innovations.
Right,
Definitely
yeah.
some innovations on our DC to DCs,
Yeah.
monolithics and other material innovations there. So
Exciting stuff.
yeah, just stay tuned and maybe we can talk again.
Yeah, I would love to. Thank you so much.
Awesome.
Thank
Thank
you.
you.